Okay, today I'm going to cover some examples. Where are these examples found? They're actually found on the SLS package on binomial theorem. At the very last part, there's this part on general term. So you actually need to watch that video if you have not done so already on general term. What I'll do for you today is to explain to you how they derive those answers. So you just give me a moment. Okay, this is actually question 1. So there are a total of 5 questions. If you have already attempted these questions already, you can actually just move on to the end of the video where you find the questions that you need to attempt before coming in for class tomorrow. But if let's say you have not attempted or you have no idea what you're doing, you can actually watch this video where I present the 5 questions in SLS. Notice that I have not written the questions down here. You actually have to go to SLS itself, attempt the questions, and these are the solutions, so to speak, of those questions on SLS. The very first thing that you need to know is that you need to know the general term is given here from the previous video. It can also be found inside your textbook as well. So T subscript R plus 1 is N choose R, A N minus R, B to the power of R. So this we actually have done it right in class, so to speak. So the next thing it is this. For question 1, what they're looking for is an 8th term. So basically, if I'm looking for the 8th term, for the general term is T R plus 1. So if you think about it, R plus 1 is equals to 8. So what must the value of R be? 7 plus 1 gives 8. Hence the value of R in this case is equals to 7. That's why I put down here R is equals to 7. So for my 8th term, T7 plus 1, T8, alright, 12 choose 7, 4 to the power of 12 minus 7, okay, is from down here, and B to the power of 7. So B to the power of 7, the 7 comes from down here. If you compute all of this, 12 choose 7 gives you 792, 4 to the power of 5 gives you 1024. How did I work out this portion here? X to the power of x over 2 to the power of 7, when you open the brackets, is x to the power of 7, 2 to the power of 7. And 2 to the power of 7 will actually give you 128. So if you key into your calculator, 792 multiplied to 1024 divided by 128, you get 6336. Do remember to answer the question. The question says what is the coefficient. So do write a statement there stating that the coefficient is 6336. For question 2 is similar to question 1, so I'll run by a bit quicker. For the 12th term, okay, so T R plus 1. So if I want the 12th term, okay, my R in this case is 11, because 11 plus 1 will give me 12. So my R is equals to 11. I will put this into my general term, 16 choose 11, 3 to the power of 16 minus 11, negative x squared to the power of 11. Moving, 16 choose 11 gives me 4368. 3 to the power of 15, you use your calculator, it gives you 243. Okay, when I open this thing here, okay, 2 times 11 will give me 22. Notice that my power, negative x squared, here is negative, alright? Why is it negative? Think for a moment, why is it that this number or this term in x here still remains negative? The answer is this. Negative 1 times negative 1 gives you positive 1. If I take negative 1 times negative 1 times negative 1, I get negative 1. Okay, notice that the number is odd down here. Negative 1 to the power of 4 will give me positive 1. So whether or not this coefficient here is positive or negative actually depends here on this index down here. Negative 1 to the power of 11, because my index is odd, what I'll get is a negative number. If I had negative 1 to the power of 12, then I'll get positive 1. So it all depends on this index here. So negative 1 to the power of 11, it will give me negative down here. So using your calculator, 4368 multiplied to 243, then multiply to this negative here will give me negative 1061424 times x to the power 22. Once again, what they're asking you for is the coefficient. So the coefficient is the number before the x term. So the coefficient here is negative 1061424. When we look at question 3, the question slightly changes in the sense that we are still looking for the general term. However, in this case, right, we're looking for very specific powers. So just now, what we actually have is we can determine the value of r. Now the question shifts such that we need to find the value of r. So in this case, if I apply, okay, to the question for my general term, I get 9 choose r. Do take note that r is now an unknown. So I have 3x squared over 2, which is the a term. I put 9 minus r. And the b term, 2 over 3x to the power of r. Okay, let me just do some simple expansion here. So if I expand this bracket over here, the 9 minus r, if you put a bracket, so 9 minus r is applied to the 3. The 9 minus r is applied to the x squared. Do be very careful here. I will zoom in. So x squared 2, do not forget to put the bracket here, 9 minus r. Okay, so the bracket, this bracket here is important, and not forgetting that the 9 minus r will also be applied to the 2 down here. Similarly, for this term over here, the power r is applied to the 2, so you get 2 to the power of r, 3 to the power of r, and x to the power of r as shown in this bracket over here. So now, if I'm looking for the term that is independent of x, essentially what we are looking for is x to the power of 0. So, okay, x to the power of 0, this independent of x, x to the power of 0 is 1. So I'm looking for the power of x equal to 0. This question is a bit different because I am just looking at the x terms, alright? So you can ignore this term, ignore this term, ignore this term, ignore this term. What I am going to focus my attention on is the powers in x, because I know that the power of x I'm looking for is x equals to 0, the term independent of x. So therefore, I'll only look at this term, okay, power in x and power in x. So if you can see, x to the power of 2 times 9 minus r divided by x to the power of r, which I've written down here, okay, what I'll get is x to the power of 2 times 9 minus r minus r. If you remember your laws of indices, a to the power of m divided by a to the power of n is a to the power of m minus n. So that's what I have shown down here. Okay, 2 times 9 minus r over here will minus r. If you solve for r, your r value will give me 6 over here. So that is for question 3. I move on to question 4. I will go a bit more quickly now. For this case, what I have done here is I have already written down the general term for question 4. Okay, then if you expand this bracket here, don't forget is 2 times 9 minus r. Over here, to make your life a bit more simple, I've actually simplified it. Minus 1 over 2x, okay, I have rewritten it as negative half, okay, multiplied by x. I have actually written it as negative half multiplied by 1 over x. So I split it up into this bracket here to the power of r, this bracket here to the power of r. Okay, once again, in this case, if I'm looking for the power of x for 1 over x cubed, 1 over x cubed can be rewritten as x to the power of negative 3. So what I'm actually looking for essentially is the power of x is negative 3. Similar to question 3, I just look at the x terms. So this one I ignore, this ignore. I will look at this x term and this x term here. X to the power of 2 times 9 minus r times 1 over xr, I will get this term over here. Using my laws of indices, I will simplify it to x to the power of 2 times 9 minus r, which is how I get to this portion here. And why negative 3? Because the power of x, in this case, I'm looking for is negative 3. If I solve, my value of r is equals to 7. Okay, question 5. Same idea here. Now I will just write out the general term. Okay, notice that when I put in my 8 minus r, it'll be 2 to the power of 8 minus r, x to the power of 3, don't forget the brackets, times 8 minus r. This case, same thing, negative 3 over 2x, I can actually rewrite it as, negative 3 over 2x to the power of r, I can rewrite it as negative 3 over 2 to the power of r times 1 over x to the power of r, which is what I have done down here. Then, if I just concentrate on the power on x terms, which is here and here, okay, what I get is x to the power of 3 times 8 minus r over x to the power of r. So looking at the coefficients, looking at the powers of x, I will get this, and I'll get this whole thing, and I'm looking for the power of x is equals to 12. Solving it, I'll get r is equals to 3. And that is how I have worked on the general term. Now, the next thing that I'll have to give you will be work. Okay, this is from your textbook, all right? So we shift away from SLS. You can go and look at your textbook itself. It's from exercise 6.2, questions 3C, 5, 15, and 18. Please attempt these questions, and I will go through them on Friday.